Hi, my name is Kashyap Merai, and today I would like to talk about how to keep your Docker container running and some of the proven strategy that we can use to keep it running. So before we jump into that, first we should understand like how Docker really worked behind the scene and then why it exited. Let's start with the first section, like what happened really when you run the Docker container. So when you run the container, it will start execution of the command which you write under the entry point or the CMD into the Docker file. And once that process starts, it can be either application code or some simple script or anything that you wrote. Once it is running, it will be keep running until that process die. We define some task to the Docker and the Docker will keep executing that task. Once that task is finished, it will be exited. The Docker container will be stopped working. Let's understand this by sample diagram, how it really works. So when you create some Docker file, you have some instruction over there like entry point or command. So when you run the container, it will start the container and Docker will assign the PID1, whatever the script or command you put as a primary process. So until that primary process is running or executing, the container will stay active and container will be in the running status. Let's say due to any reason that process exit, maybe you are running a web server, it crash, or you are running some batch script that will finish executing. At that time, the process itself is exit. That means the primary process ID PID1 that was initially running, now it stopped working. And since there is no more active process, there is no purpose for the Docker container to be keep running. So now let's understand the same concept with one example. So here I have one simple Node.js file and I have one package.json in Docker file. The important point here too is this command. When you start running the Docker container from this Docker build image, it will be executing this npm start as a command. That means this command will be assigned as a primary ID1, so your container will be also running. Let's say for any reason, this Node.js container crash, stop working. At that time, your container will also stop working. So I have already built the image. So let's check that. As you can see, the Node.js server image is built. Docker run -d for running in the detached mode background. And let's also export the port 3000 and Node.js server. Okay, let's verify. As we can see, our Docker container is up and running. There is a command also that we mentioned and also the port. We can see the hello world. That means our container is running as of now. Let me go into the container. So Docker exec-it and 256, which is our container ID, and maybe sh. So now I'm inside the container. So let's run the ps aux command. So we see what are the process right now that's running inside the container. So as you can see, the npm start command with the PID1. That means this is our primary process, the first process that we run. If you can see our Docker file, that's our entry point or command, npm start. That means until this process is running, the container will be running. Once it is die, the container will also stop working. Let's try to kill one. We just instantly kick out from the container itself. Let me verify. As you can see, no active running container. If I add -a flag, I can see the container is exited. So the reason is simple. Since the PID1 is dead, there is no more purpose that this container is serving. Hence, the container stopped. So this is how really the container works behind the scene. Okay, so let's talk about the first strategy, how we can keep our Docker container running. So the first command that we would like to discuss is tail. So when you pass the tail-f to the dev null, so this is kind of creating a loop where the tailf wants to read the new content while the dev null is keep discarding the content. That means this is a perfect loop. Okay, so let's do the demo with the first command, tailf dev null. So here we are going to use the Alpine as a base image. So as you can see, this image has nothing to do as a task because we use this OS image as a from, like base image. So if I run this command directly, it will always crash. Reason, there is no task for the OS images. So let's see the behavior. Okay, let's check. You see, nothing is running. If I do docker ps-a, you can see the Alpine image started and its exit. Let's say I want to keep this container running, then you can just simply add this command, tail f dev null. Okay. Now if I check docker ps, you can see the container itself is Alpine, it's running, and now you can do any debugging you want with exec-it and 994, which is my container. And if I do ps-aux, the process ID, which was initially the sh, here we replace it with our own, and that becomes the first PID. And since it is running, our container is also keep running. So this is the first method. Now let's talk about the second method, using the interactive mode. So this is a default feature provided by the Docker where you can pass -t option, which is basically you want to run the container as an interactive mode. So if you pass that option, the Docker container will also keep running. So let's start the same example by running the Alpine and make it interactive to keep it running. So I'll copy this command. The important key is -t here. I run it. Let's check. Now we can see we have the C89, which is the current Alpine image we run, and it's also keep running and it's up. Even with the first PID, this time it's keep running. Why? Because we run it in an interactive mode. We can still do docker exec-it C89 as such. Let's check the PID here. As you can see, even though the PID is being bashed, this is the interactive mode for us. Then it's keep running. Let's talk about third method, which is a sleep infinity command. So sleep infinity command basically inform the system to sleep infinite time, which will prevent the Docker from shutting down. So here I will copy this command, go to the terminal, and you can see pass the sleep infinity. Okay, we got the container ID. Let's docker ps. Okay, cfdd. This is our container, sleep infinity, and it's also running. That means we also make third way of our Alpine container running. Let's go inside. sh. Then we will do the ps-aux. You can see the sleep infinity command become the first PID, which is what we want. Okay. Let's go out. Let's talk about the fourth method, which is an infinite loop script. This is essentially the same as a sleep infinity, but slightly different command. So let's try to run this one. No exit forfeit. So let's start. Okay, we got our container running. Let's verify the same. Now we have D3E with the sleep 5 seconds. So it's also running. Docker ex ec-it d3e sh ps-aux. Same way we verify, our root ID become this. Okay, so let's talk about the fifth method, which is using a socket method. This is slightly different command, but it requires the netcat as a utility which should be installed within the container. If you have it, you can use this method as well. So let's do the demo of this one too. So here we pass the netcat listen to the bot 3000. Okay. Okay, docker ps. Here we have be7, which is essentially the same ID. Now the pod running. So our container is also keep running. Let's docker exec-it be7 sh ps-aux. As you can see, our first process ID is replaced with the netcat. Okay, now let's talk about the method number 6, which is using the cat command. So let's do the demo to understand this command as well. This run. Okay, now let's verify. So we have 259, which is running with the cat. So if we do the docker ps docker exec-it 259 sh and do the p as aux. You probably see the cat command is running as a primary ID, and that way the container will also keep running. Okay, so far we have run 6 different methods, and all of them are basically passing some simple command that can create a loop, and then our process container can keep running. This method is slightly different. This method is mainly useful when you have to have something long running task, or you want to pass some additional output or argument. So this script you can add it under your development workflow and utilize as you need it. So the code itself is very simple. Let's check it out. So here I have prepared the keep alive script. Basically, it will just do the while true and sleep. So the container will be keep running because we don't have any condition over here. And there is a one Docker file. Just to show you how you can utilize, we copy the keep alive sh file, provide the chmod plus x to the execution permission, and then run that script as a cmd. So let's run this. So for that, I have already built the image, keep alive image, lattice. Then if I want to run docker, run -d, chmod, keep alive. Okay, so the container is running. Let's check. As you can see, the container 2a5 is running. That's docker exec-it 2a5 sh ps aux. So as you can see, our script itself is running. Let's exit from the container. Okay, so additionally, let's say if you are using the Kubernetes environment and you are facing the similar issue, you can follow the same method that we have discussed previously. All the 6 or 7 methods that we have discussed will work perfectly fine within the Kubernetes environment also. Okay, so after learning about how the Docker works and how to keep your container running with some of the command and demos, let's talk about some of the best practices when you want to keep your container running and manage the long running processes. So I have 2 examples for the best practices here. So let's say that if you're running your Node.js application and you want to manage your application as a process manager, then PM2, it would be an ideal choice. You can use PM2. It is a process manager for the Node.js, so that PM2 application will take PID 1, and then it will manage multiple Node.js application as a secondary PID. Another option is supervisor. If you're coming from the Linux background, you have probably heard about this one. So it manages as a client-server model. If you are aware about the PHP or Laravel, then you know that in that application, you might want to run your web server, let's say PHP web server. You might want to run some batch files, some batch job, some cron or schedule jobs. Then the supervisor can be a best option for you to run. Same as a PM2. Supervisor will also run as a PID 1 and then spawn some of the other PID of your application. So that way, if any of the application crash, your container will not stop working, but the supervisor will take care of that and also spawn another process for you. Okay, last but not least, talk about some of the troubleshooting or common issue with the keeping your container persistent. So even though we have discussed so many methods to keep your container running, some best practices, but sometimes issue might happen and it's unfortunate. So best way to debug those issues is probably checking by the Docker logs and running some diagnosis. So some tips that I have for you is that you can check your Docker logs and the exit code itself tell you something. For an example, I have 2 Docker codes that can be helpful. If the Docker container exited with 0 status code, that means the container exited successful completion. That means there will be no error within the container, but it finished its process and it exited. Let's say when the Docker container exited one code of 137, then it means that it is terminated because of the out of the memory error. So from this status code itself, you can easily judge why the Docker container stopped working and how to prevent those issues. Another option that I have is optimizing your container for the resource to prevent the crashes. let's say we face the 137 code, our application, node application is running and it exited with 137. Resource might be out of memory. So better to guard your application that it will not take entire resource available within your node, because you might have multiple applications running within the Docker environment and you don't want your one Node.js application to take all the available memory, and that way the other container might suffer. So you can use the resource limit within your container. So when you run your Docker container, you can provide how much memory or CPU you want to restrict it to. So this is a good practice, and you should always use this memory and CPU limit within your container environment and Docker, and of course within the Kubernetes too. So I think that's it for this video today. We have learned, if I want to summarize that, we have learned multiple things, such as what happened when you run the container, why the container stops, 7 different methods, how we can keep our Docker container running, some of the best practices, and troubleshooting idea. Let me know if you like this video. If you want to learn more about this, please check out my blog, theo2devops.com, where I posted the multiple DevOps related tutorial and troubleshooting tips. Thank you so much.